Hi everyone, welcome back to Module 1.3 where we're answering the question, is NGSS just a scientific method? Up until this point, I think you've gotten from doing the discussion board activity in the Google Doc, I think you've probably reached the conclusion that the scientific method doesn't square incredibly well with what real science is like, right? Real science is flexible, it's not linear, it involves a lot of the creative process, it involves a lot of collaboration with different people in different places, right? Whereas the scientific method doesn't have those components necessarily built into it. So we started last video by looking at these posters, and now I'm going to show you this poster that I got from thewonderofscience.com that kind of shows what inquiry can look like in the NGSS classroom, right? One thing I want you to notice when you first look at it is that there is an order. So we're not saying that like, oh, real science doesn't follow an order. You just do these different practices at any time that you want to figure out something about a phenomenon. No, there definitely is an order, right? You experienced that in lesson 1.2 with Heather, right? You experienced the phenomenon with the cruise ship data of the asymptomatic and the symptomatic passengers. The first thing you did was ask questions, right? So asking questions is almost always going to be the first thing you do when approaching a phenomenon. After you asked questions with Heather, you developed a model, right? Came up with some sort of idea of how this works, right, to answer some of the questions you came up with. What's important to realize, though, is that even though there's an order, it's much less of a prescribed order, right? So, like, after asking questions, you could develop a model to explain it. You could use mathematical and computational thinking to attempt an explanation, or you could do a traditional explanation, right? Like making a hypothesis or prediction, or just explaining what you think, what could be causing it. After this, you go into planning and carrying out investigations. Once again, it's not going to be as prescribed what that investigation looks like, right? I'll get into this in a second, but right, different students or different groups could be performing different or doing different investigations. The investigation might be a hands-on experiment, or it could be accessing data that's already been collected by scientists, right? Or it could be doing a research project, which would overlap a little bit with this practice right here. It's probably hard to read, but it says obtaining, evaluating, and communicating information. After that investigation, you move into the argumentation piece, right? Bringing your evidence to the class or whatever the community is, and using the evidence and collectively trying to figure out this phenomenon based on all the evidence we came up with. It's really important to see this arrow then points back to asking questions, because as we all know, once you complete that whole process, more questions will come out of it, right? So, and these right here are the cross-cutting concepts, which we'll get into more in Module 2, but for now, I'm not gonna address those. So back to the question we asked at the beginning, scientific method versus NGSS, are they the same thing, opposites, different but compatible? So definitely not the same thing, right? However, definitely not opposites. Different but compatible, definitely different, right? And I'll let you kind of make the decision, like how compatible they are, right? There's a lot of overlap, but also there's some things lacking with the scientific method that we kind of want to move away from. Less of that linear thinking and more towards an understanding of the true nature of science. So the question I have next is, why does it matter how students view the scientific process? Why does it matter if they view it as being scientific method, follow a list of steps, conclusion, versus, what we learned is real science from that video? Well, according to Appendix H of the NGSS framework, one fundamental goal of K-12 science education is a scientifically literate person who can understand the nature of scientific knowledge. I think it's important to underscore, most of our students aren't going to become professional scientists someday. However, even the ones that don't, we still want them to be scientifically literate, right? And to be scientifically literate, they have to understand how science works. I want you to think about this in terms of COVID-19, right? COVID-19 over the last 18 months has provided the world an opportunity to see how science works firsthand, right? And I want you to think, just in your head, like, how might you, and when I say how it works, right, you hear some people complaining about varying guidance from public health authorities, right, around like, does mask work, does it not work? They used to say it didn't work, but now they say everyone should wear masks. Like, I don't know who to believe. Or, the coronavirus can be passed on surfaces, but now they're saying it's airborne. Like, the science, we can't trust science, right? Like, this is not the scientific method, right? And so how would you view those differing ideas coming, or differing conclusions coming out of the scientific community over the last 18 months if your view of science is the scientific method, where it's more linear, where you get a conclusion, that's your final conclusion, you move on to the next question, right? Versus one, let me move my face again, that looks more like this, right? Where testing of ideas with moving towards exploration and discovery, community analysis and feedback, and then back to the testing of ideas, and then benefits and outcomes, right? This is the graphic you saw in that video you watched, right? How would that change the way you're viewing the how we're seeing science unfold during this pandemic. On August 22nd, 2021, so just very recently, the New York Times published an article that I'd highly recommend you read as a science teacher because it really is motivating. And it specifically it relates to Americans, but I think what it proposes is very generalizable to other parts of the world as well. It says the U.S. is getting a crash course in scientific uncertainty. I'm just going to read a couple brief excerpts. The scientific understanding of the virus changes by the hour, it seems. The virus spreads only by close contact or on contaminated surfaces, then turns out to be airborne. The virus mutates slowly, but then emerges in a series of dangerous new forms. Americans don't need to wear masks. Wait, they do. Americans are living with science as it unfolds in real time. The process has always been fluid, unpredictable, but rarely has it moved at this speed, leaving citizens to confront research findings as soon as they land at the front door. A stream of deliveries that no one ordered and no one wants. Most Americans have a decent grasp of basic health concepts. Exercise is good, junk food is bad, but many are never taught how science progresses. If you find this, I'll link this in the slides, but if you find this article online, they also have some studies linked in there of this to back up this claim that many are never taught how science progresses, right? So you're seeing, like, even in something like the COVID-19 pandemic, how you view how science works can affect the way you respond to things like public health guidance, right? So how does this apply to the science classroom? I want to kind of make it hopefully a little more practical in these last couple slides. So as we mentioned before, in lesson 1.2, you asked questions, you developed a model about the cruise ship data, and then generally what will come after that is planning and carrying out investigation. Like we said earlier, and like what was mentioned in lesson 1.1 with Britta, oftentimes what the scientific method results in is this idea of a linear cookbook lab, right? Whereas what we want is best, and there is at times a place for that. However, we want to move away from that into more of like what we call like an inquiry lab that reflects real science. So what do those two things mean? Okay, so now, I'm saying the scientific method type lab versus real or investigation versus a real science investigation, right? In a traditional investigation, students follow lists of steps in order to confirm something they've already learned about, right? Whereas in real science and with what we'd want to see in NGSS, students plan and design an investigation to answer one of their own questions, right? So a question they don't know the answer to, but they're going to plan an investigation to figure it out. In the scientific method, all students do the same investigation, right? Whereas with NGSS or real science, students may, I'm not going to say always, but may carry out different investigations, or maybe different groups will carry out different investigations, testing different variables, using different materials, answering different questions. And last but not least, with a more traditional lab, students share out their data at the end, mainly to confirm that everyone did the lab correctly, right? Whereas with real science, students engage in argument from evidence that they've collected in an attempt to collectively understand the phenomenon under investigation, right? Moving from the yellow over here to the green can feel really intimidating, right? I want to say that, like, you know, it feels like there definitely is a relinquishment of control that happens between the yellow and the green. However, there is an element of control that teachers should, and really the only way to make it practical is to have some control that teachers have over this process, right? Whether it's providing the materials and having kids design investigations using the available materials they have with them, or things like that, okay? So, but this is definitely like the ideal we're moving towards, right, when it comes to planning investigations. So what I want you to do lastly in this module is look back at the questions you asked about the cruise ship data in lesson 1.2, okay? I want you to choose one question, and then on the Padlet board, there's going to be a column labeled 1.3, and in that column, I want you to briefly describe what type of investigation you could design to answer one of your questions, okay? Obviously, if you're doing this with students in class, there are going to be lots of limitations as far as the materials, as far as access to the population of people you need to do this test, or whatever it might be. But for the purpose of this just a little bit of a reflection activity, for the purpose of this, just like ignore limitations as far as constraints on your materials right now, okay? And I want you to post at the top of your little sticky note on the Padlet board what question you're planning to answer, and then briefly summarize what your investigation would look like in order to answer that question, okay? Once you do that, scroll through other people's investigations, and hopefully gain a little bit of an appreciation for like the divergent nature of the investigations, right? People doing lots of different investigations because we have a lot of different questions to answer. Once you do that, I'll also post one other resource. This is a resource in wonderofscience.com that kind of walks you through the inquiry cycle and how to do each of the different steps. Like I said, it's not super prescriptive, but gives you options of ways to do them. And last but not least, this is the last lesson in Module 1. So there is going to be a discussion board you're going to see on Google Classroom for final reflections. In that discussion board, we're going to use what's called a shaping up framework. You're first going to share something that's from this module, not just this lesson, but from the module as a whole, that squares with your beliefs. In other words, like something that you heard or learned that like reflects or affirms what you already believe, okay? Then you're going to write down 3 points to remember, 3 things you want to remember from Module 1. And lastly, 1 question that's still circling in your mind. So square, 3 points, triangle, and a circle. You can kind of just post on the discussion board like this, right? Just put squares with, 1, 2, 3, question circling, question, and then submit it. That's everything for this module. I want to thank my face again. Thank you again to Tri Association for making this course possible, and I look forward to engaging with more of you on the discussion board and on the Padlet. Bye-bye.